So we will try to understand first, second and third normal form, and after that we will see whether this uh, functional dependency is in PCNF or not. So using this single question, we will try to understand all the concept of normalization. So let's begin. So as you know, any table, if any table that contained no multi-valued attributes or no composite attributes, then it is in first normal form. So it is already in first normal form. As you can check, there is nothing to worry about it, because any question which is given must be in first normal form. So all we need to do is to check whether it is in second normal form or third normal form. So if it is not, then we will try to make it in second and third normal form. So first we will try to find whether it is in second normal form or not. So the rule for second normal form is to find first of all the candidate key for these questions. So how to find the candidate key? So we will check the first, we will see whether we would have single value candidate key or not. So for that we will find A plus, B plus, C plus, D plus and E plus. If all these contain, if any of these contain all these values, then it is in candidate key, or if it is not, then it will be not included as in candidate key. So as you can check here, by using close-up formats, we will get only at AB. So I will show you how. If we take AB plus, then we will get AB, because we can get A and B from here. And now when we have AB, then we can get C. So we will get C, and from B we can get D, and from D we can get E. So all the values we are getting from AB. So if as we have done here, by finding the closure for AB, we got all the values. So AB is the candidate key here. So AB will be our candidate key. Now we would find the partial dependency. How to find the partial dependency? It is very easy. If, listen it carefully, if any part of the candidate key is determining something, then it will be a partial dependency. So if either A is determining something or B is determining something in this, then it would be a partial dependency. So we can check it here. Here we are having B, which is determining D, so it will be a partial dependency. And if anything which is a non-prime attribute, so what is non-prime attribute? Non-prime attribute are those which are not in the candidate key sections. So as we can see here, D and D is not here, so there is non-prime attribute, a determining non-prime attribute, so they are called transitive dependency. We shall see it later on while determining our third normal form. So after finding the partial dependency, we will just find the closure for the B. Why B? Because this one is only the partial dependency. So we will find the B plus. So from B we will get B, and by looking this we can get D, and from D we can get E. So this thing we are getting from B plus. Now we will just divide this into the tables. So as we initially have A, B, C, D, E, and from B we are getting D and E, so D and E will be cut off from this, and whatever left will be our second table. So A, B, C will be in another table, and B, D, E that we got from our B plus would be in the first table. So this and this table is totally lossless. So what is lossless? Lossless, we mean to say that the common attributes, that is here as you can see, B is the common attribute, it must be a candidate key. So from this you can check it that we can get everything. So So this is the lossless, and now this will be in second normal form. Okay, I think you all understand everything. Now from this we can find B determine D, and here D determines E. It is very much clear from this. Now, as we have discussed it earlier, D determines E, that is a non-prime attribute. E determining something, then it is a transitive dependency. Now, if we would have any transitive dependency, then we will find the closure for that. So we will find the closure for that. Now we are moving toward our third normal form. Up to this, we are clear about for second normal form, as we got our second normal form tables. So now we are moving to our third normal form, where we have to find the transitive dependencies. So we checked how to find it. Now transitive dependencies, when non-prime attributes is determining another non-prime attributes. So we will find closure for D plus, and from D plus we will get D from D, and as you can see here, from D we can get E. So this is all we get from D plus. Now D plus will DE, so it will make a table for DE, whatever we are getting from here. And now from this you can see B determines D, so B determines D will get another table, and whatever left, that is in A, B, C, D, we are out with D, E, and then B, and we are left with A and C. But as you can see here, this table does not change. Why? Because we don't have any TD here, because as you can see here, AB is a candidate key, and this candidate key is determining non-prime attribute. We will just understand one thing, that we will get TD only if non-prime attribute is determining non-prime attribute, not the candidate key is determining non-prime attribute. This would not be the case for the TD. So this here we are not getting TD, so we will not disturb this table. Only we will divide this table. So from this table we can get this two table, and this table